All right, Mr. Ahmed here for 4.2. Our goal for today is to write equations in point slope form. So the essential question is, what is point slope form? And how do I use it? Okay, so how do we actually use that point slope form? So the first thing we're going to talk about is point slope form. It is y minus y1 equals m times x minus x1. M is still the slope, and x1 and y1 is a point on the line. So x1, y1 is just a point on the line. Doesn't matter where, it's just a random point that exists on that line. So why do we need to use another formula besides slope-intercept form? Because oftentimes there are lines in linear models where we don't know the y-intercept. And this is the easiest way for us to also find the y-intercept. So this form is going to be much easier to utilize rather than plugging it into slope-intercept form, picking a point, solving for b, and starting over again. All right, so that's kind of a long way. This is much shorter. So the first thing we're going to do is just write the equations in point-slope form, and then after that, we're actually going to use point-slope form to end in slope-intercept form. So point-slope form, we got to memorize this. Y minus y1 equals m times x minus x1. So keep writing it over and over again so you can memorize it. All right, a couple key details here. X1, y1, that's one of the points. So I'm going to highlight that x1, y1 in yellow. That is where we're going to substitute in the point. All right, our point is 2, -5. So that's what we're going to plug in to point slope form. When we label out our point, okay, our 2 is our x1, our -5 is our y1. So these are the values that we're going to plug into this equation, right? Where it's yellow goes in for yellow. Our slope is still -3, so m is -3. And I just got to plug these values in. So y stays as the variable, y minus y1. So minus, we have to be careful with our signs, minus a -5 equals m, that's -3, times x minus x1 is 2. So for us to keep it in point slope form here, we just want to change this minus a negative into a positive. So y plus 5 equals -3 times x minus 2 in parentheses. And that is finished in point slope form. Okay. Notice how this value changed to a positive. We have to keep in mind when we use this that a negative number had to go into the equation to change this to a +5. All right, another example here. X1, Y1, that's my point. Here is my slope. M is 1/2. So y minus y1 equals m times x minus x1. This is easier to use than slope-intercept because I do not know the y-intercept, all right? X is not 0. So I can't just plug it into slope-intercept form. So y minus 5 equals m 1/2 times x. Now you should notice this. Minus a negative will change to a +4. That way we don't have to do that middle step like we did on the other one. Okay, so just be cognizant of when you put in a negative, the original sign is minus. Minus a negative changes to a positive. All right, using the graph, notice I cannot tell exactly where the y-intercept is. I might think that's 1.5, but I'm not sure. It might be 1.4. So I have 2 points. I have -2, 3, and my other point is 3, -1. When I'm given 2 points, I can pick either one to put it in for our x1, y1. All right, this one could be the one I use, or I could use this one. Doesn't matter. But I still need to know the slope. What's m equal to? On this one, it's a graph, so I'm going to count it. It's going down. Down 1, 2, 3, 4. -4 over 1, 2, 3, 4, 5. So our slope is -4 over 5. I think counting it's a little bit easier. You could have also used the slope formula. I'm going to pick this point to be x1, y1. You could have used this. Doesn't matter. I'm using -2, 3. So into point slope form, y minus y1 equals m times x minus x1. Notice I'm writing that over and over again. That helps you memorize it. So y minus y1, that's 3. Y minus 3 equals m, negative 4 over 5, parentheses, x minus x1. That's a negative, so minus a negative changes to a positive 2. That is completed in point slope form. Okay, so if we have to leave it in point slope form, we leave it like that. Now keep in mind, if we want to change it to slope intercept form, we would have to isolate the y. We will do that here further along in this lesson if we need to change it to slope intercept. Okay, another example of looking at the graph. All right, on this one, again, I can't tell for sure exactly where it crosses that y-axis. I mean, it might be, it looks like it's going by 2, so that might be 3. I'm not sure. This graph's a little tricky. 2, 4, 6, 8. So it's not 1, 2, 3. I noticed that 2 right there. It told me I'm going by 2s each time. So I still need to pick 2 points that I can see exactly. I see one here, and I see one here. So the 2 that I see exactly are negative 2, negative 4. And the other one I see is 6, 0. So those are the 2 exact points that I saw. I'm going to count my slope up 2, 4 over 2, 4, 6, 8. So my slope m is equal to up 4 over 8. Reduce that to 1 over 2. Okay, reduce that down to 1 over 2. We'll let this one be x1, y1. We'll use that point, 6, 0. So y minus y1 equals m times x minus x1. We're using that because I don't know the y-intercept, so we're using point slope. So when I plug it in, y minus y1, well, y1's 0, so I have y minus 0 equals m, which is 1/2, times x minus 6. Now, if I were to finish this by getting it into slope-intercept form, just like this equation asks, I need to isolate the y. So for me to isolate the y, well, y minus 0 is just y. Y is isolated. But we also want to distribute here so it ends in slope-intercept form. So 1/2 times x is 1/2 x, and 1/2 times negative 6 is negative 3. Now when I looked at that graph, I said, I didn't know if that was negative 3 for the y-intercept. Turns out it is negative 3. So this is the easiest way to find slope-intercept form when I do not know the y-intercept, okay? So do number 5 and 6 on your own. Go ahead and push pause, give these a try. All right, make sure you read the instructions closely. This one says point slope form. So I have to end in point slope form. So y minus y1 equals m times x minus x1. That's where we end. x1, y1. Y minus 2 equals m, which is 5 times x minus 1. Point slope form is complete. Okay? Points. I didn't have my picture very well shown here. I'm going to backtrack here just a second. x1, y1, plugged it in. Y minus 2 equals 5 times x minus 1. Okay? Sorry, I didn't have that shown very well. Next one says we're ending in slope-intercept form, so I need to isolate the y, but I don't know the y-intercept. So I am going to have to be super careful here, and let's calculate the slope first. Over 2, up 3, so the graph is going by 1s. So I'm going up 1 over 1, 2, 3, 4. So our slope m is equal to 1 over 4. Pick either point to be x1, y1. I'm going to use 2, 3. So 2, 3. x1, y1. I could have used 6, 4. Choice is yours. All right. Y minus y1 is 3 equals m 1/4 times x minus 2. Notice I didn't write down the equation this time. After a while, we should have that memorized, so you can skip that step of writing the original equation. All right. We still need to isolate the y to end in slope-intercept form. So for me to isolate the y, I need to distribute my 1/4. And as I distribute my 1/4, I have 1/4 x. That's my slope. 1/4 times negative 2. Oh, that's not a real easy one. 1/4 times negative 2. I'm going to actually pull up my calculator for that, and we'll see what I come up with. 1 divided 4 in parentheses times negative 2 is negative 0.5, so that's negative 1/2. So minus 1/2 equals y minus 3. Now to isolate the y, I still need to add 3 to both sides, only with the like terms. Those cancel. And I got y equals 1/4 x plus. So we have 3 and a negative 1/2. 3 and a negative 1/2 is 2.5. So my y-intercept is 2.5. Does that make sense? Up 2.5? Yes, it does. Okay. Now the tricky ones, all right, we're bringing back this here function notation, which no one really is appreciative of, but it still exists. So when I have the function notation, f of x, so x is 6, y is 3. That's my first ordered pair. Second ordered pair, negative 3, negative 3. All right, I don't know the slope. I have to calculate the slope when I don't know the slope. So m equals y2 minus y1 over x2 minus x1. Plugging in my values here, I'm going to pick that up just a little bit since we've done slope so many times. So negative 3 minus 3 over negative 3 minus 6. All right, negative 3 minus 3 is negative 6. Negative 3 minus 6 is negative 9. So that reduces to 2/3. Okay, so I know my slope is 2/3. Now, it asks us to write this as a function, right? A linear function. So I need to end in function notation. I'm still going to isolate it using point slope form. So I still am going to go y minus y1 equals m times x minus x1. After I isolate the y, I will end with our function notation, okay? So I'm going to use this point for x1, y1. Could have used either one. So when I plug it in, y minus 3 equals m 2/3 times x minus x1 is 6. Okay, distribute 2/3 x. 2/3 times negative 6, using my calculator again. 2 divide 3 in parentheses times negative 6 is negative 4. So minus 4 equals y minus 3. Now we still need to add our 3 to both sides. Plus 3 cancels off. Y equals 2/3 x minus 1. So that is in slope-intercept form, but we have to end in function notation. So instead of a y, we would call it f of x equals 2/3 x minus 1. So it's just one little change there at the end. Just need to change it to function notation instead of a y. All right. We got 2 examples left here, and I think the video got a slight bit long, so I may make a part 2 video for this. We're going to cut it off because this is probably about another 5 minutes. So that's the end of video number 1 for 4.2. I will make part 2. Have a good rest of the day.